So as we read this problem, f is an antiderivative of x squared over 1 plus x to the fifth. What does that really mean? That means f equals the antiderivative or the integral of x squared over 1 plus x to the fifth dx. Again, that vocabulary right there, antiderivative, is the same as a integral. Then they've told us f of 1 equals 0, and they want f of 4. So the other thing that they're saying in this question is that f of 1 would be whatever we started at, and in our case we're going to start at 0 because that's what f of 1 is. Sorry, not f of 1 here, but f of 4. If we wanted to find f of 4, we would start at 0 and we would add the integral from a lower limit of 1 to an upper limit of 4, x squared over 1 plus x to the fifth dx. It's really this idea that we're going to have a starting value plus a time initial to a time final velocity dt, if we were going to think about this as position, x at some time. Of course, this would have to be a dummy variable so that those were different. But that's kind of what this is relating to that I think everybody has seen. If f of 1 had been 7, then this would have been a 7. So now as we continue with the problem, a calculator is allowed, so I'm going to go right to Math 9, and I'm going to punch in exactly what we see here. The calculator gives me this integral as 0.3756, which we would round to 0.0376. Most important things that we reviewed here, the idea that the antiderivative is the same thing as the integral, and this equation right here. I can find a function value at any point that I want, any time or any x that I want, by figuring out where I start and then taking the definite integral from the place that I know, the x value that I know, to the x value that I want.